Hi everyone, I am Dr. V.H. Nishok from EC Department, SNS College of Technology. Here we are gathered to discuss the topic Peak Detector using operational amplifier from the subject Linear Integrated Circuits. So in this session we are going to discuss the topic Need for Peak Detection and operational amplifier for accurate peak detection, peak detector circuit, working principle, key characteristics and with it applications. So here we can see the need for peak detection. In many of the electrical signals vary along with the time. So here we need to know the highest value of a varying signal. So that is nothing but the peak value of any electrical signal which varies with time. So important, it is this measurement of peak value is very important in many real-time systems, and also this measurement will helps in protecting the circuit from over voltage conditions. So based on the conventional circuits, we can identify the problem. The conventional circuits cannot store the peak value. So whenever the signal vary along with the time, the conventional signal have the limitation of cannot be storing the peak value, and also the diode used here will cause the diode drop across the voltage 0.7 volts. So this, because of these two major limitation, the accuracy in the measurement of the highest value or peak value is missing here in the conventional system, which is very much useful in instrumentation applications. So here we are identifying need a circuit that can detect and hold the true peak value with accuracy. So here based on the previous problem identified, we are implementing or we are introducing use of operational amplifier for accurate peak detection. So here operational amplifier in this circuit, if you see, operational amplifier is connected along with the diode and the capacitor. Capacitor starts to charge, while charging it starts to store the peak value, and the operational amplifier eliminates the diode threshold error. So the whichever error that introduced by diode in 0.7 volts in the previous conventional circuits, so that is eliminated here with the help of the operational amplifier, which is most suitable for the many applications like low amplitude signal processing applications, and also it provides better stability and better accuracy when compared to the conventional circuits. Coming to the working principle of peak detectors. When the input is positive half cycle, diode starts forward bias condition and it starts to conduct, and the capacitor charges quickly to the peak value. So when the negative half cycle, so during the turn of the negative half cycle, diode become the reverse biased and no signal flow through the diode, but the capacitor holds the peak voltage. So until the next positive half cycle, capacitor holds the peak voltage, and it will in the next half cycle, if any highest value comes, it will be stored further in the capacitor. So coming to the waveform discussion of the peak detectors, we can see the input and output waveforms. The input waveform vary continuously with time. During the positive half cycle, capacitor charges to the peak value, and during the negative cycle, the capacitor retains the stored peak value. So output waveform remains constant and detected maximum value until a highest peak appears. So whenever the next highest peak appears, that will be measured and stored here with the help of the capacitor. It is similar to the flow of water into the water tank. So whatever the highest value, when we are giving the power, so that will be stored into the water tank, and when power is switched off, the tank is retained, water is retained, and when some or other time power is given, and further the water level will increase and it will be stored further. So this is the best example for our peak detector example. So coming to the key characteristics of the peak detector. So it detects and holds the peak value, and the high input impedance due to operational amplifier, which provides the high input impedance, which will reduces or minimizes the loading effect in the circuit, and low output ripples will occur because of this operational amplifier using peak detector, and accurate peak measurement is possible, which is mainly useful for instrumentation applications, and the circuit responds quickly to changing signals. So this represents the fast response. So these are the key features or key characteristics of the peak detector using operational amplifier circuit. So coming to the advantages and applications of the peak detector circuit. So the main advantages are accuracy and low error, fast response, and simple design are the main advantages of our peak detector circuit. And coming to its applications of peak detector, where it is used. So it is mainly used in audio envelope detection, and it is used in AM demodulation, and mainly because of its accuracy it is mainly preferable in instrumentation systems, and sensor circuits use them to capture maximum signal values. Since the capacitor retains the highest peak value, so it is very useful in sensor circuits applications. So this is the time for the summarization. So in this video we started seeing what is the need for detection, peak detection. So on the problem definition of the conventional circuits, and how the problem is overcome with the help of the peak detector circuit, and its working principle, key characteristics, its advantages, and with its applications, we are concluding this topic. So coming to the assessment part, here we are having a question: dash stores the peak value, peak voltage value in the peak detector. The option B, capacitor, is the right answer. And what is the main function of peak detector? The main function of peak detector is to detect and hold the maximum value of a signal. That is the right answer here. So coming to the finally, these are the books and the materials we have utilized for our video as a reference. Thank you all for joining the session. We can join in the next session.